the fastest way to deploy multiple computers with identically configurations, especially when those computers run in a virtualized environment such as Microsoft Hyper-V, is to clone those computers. Cloning copies the virtual hard disks of the computers and changes minor configurations such as computer names and IP addresses to be unique. Then the computers are immediately operational. This process, also referred to as provisioning computers, is a central technology of private clouds. Prior to Windows Server 2012, you could clone domain members, but you were not able to clone domain controllers. In Windows Server 2016 and Windows Server 2012, you can clone domain controllers. The following scenarios benefit from virtual domain controller cloning: rapidly deploying additional domain controllers in a new domain, quickly restoring business continuity during disaster recovery. You can restore ADDS capacity by using cloning to quickly deploy domain controllers. Optimizing private cloud deployments. You can leverage the flexible provisioning of domain controllers to accommodate increased scale requirements. Rapidly provisioning test environments. This allows for the deployment and testing of new features and capabilities before a production rollout, quickly meeting increased capacity needs in branch offices. You can do this either by cloning existing domain controllers in branch offices or by cloning them in the data center and then transferring them to branches by using Hyper-V. Cloning domain controllers requires the following: a hypervisor that supports virtual machine generation identifiers, such as Hyper-V in Windows Server 2012 and later. Domain controllers as guest operating systems based on Windows Server 2012 and later. A domain controller that you want to clone, or a source domain controller that must run as a virtual machine guest on the supported hypervisor. A PDC emulator that runs on Windows Server 2012 or later. It is possible to clone domain controllers running Windows Server 2012 when earlier versions of domain controllers exist in your environment. However, the domain controller that holds the PDC emulator FSMO role needs to support the cloning process. The PDC emulator must be online when the virtual domain controller clones start for the first time. To help ensure that ADDS administrators authorize cloning virtualized domain controllers, a member of the domain admins group needs to prepare a computer for cloning. Hyper-V administrators are unable to clone a domain controller without ADDS administrators, and similarly, ADDS administrators are unable to clone a domain controller without Hyper-V administrators. Preparing the source virtual domain controller. To prepare to deploy virtual domain controllers, follow these steps. 1. Add the source domain controller to the clonable domain controllers group. 2. Verify that the apps and services on the source domain controller support the cloning process. You can do this by running the following Windows PowerShell command: Get ADDC cloning excluded application list. You must remove or test any apps or services that do not support cloning. If they work after cloning, put the apps or services in the custom DC clone allow list.xml file. You can create custom DC clone allow list.xml by using the same command, appending the parameter generate XML. Optionally, you can append the parameter vForce if you want to override an existing custom DC clone allow list.xml file, as shown in the following syntax. Get ADDC cloning excluded application list, generate XML, force. 3. Create a dccloneconfig.xml file. You must create this file so that the cloning process recognizes it and creates a new domain controller from the clone. By creating this file, you can specify a custom computer name, TCP, IP address settings, and the site name where the new domain controller should reside. If you do not specify one or all these parameters, a computer name is automatically generated and the IP address settings are set to dynamic. This requires a dynamic host configuration protocol, DHCP, server on the network and assumes that the domain controller clones reside in the same site as the source domain controller. You can use Windows PowerShell to create the dccloneconfig.xml file, as shown in the following syntax. New ADDCCloneConfigFile, clone computer name, string IPv4 DNS resolver, string OUPath, string site name, string. If you want to create more than one clone, and you want to specify settings such as computer names and TCP, IP addressing information, you need to modify the dccloneconfig.xml file. Alternatively, you can create a new, individual one for each clone prior to starting it for the first time. 4. Export the source virtual domain controller. Preparing multiple domain controller clones. If you want to prepare multiple domain controller clones, do not provide any additional parameters and allow the automatic generation of the computer name. In addition, use DHCP to provide TCP, IP addressing information. Alternatively, you can customize each clone by creating individual DCCloneConfig.xml files. To do this, follow these steps. 1. Create the cloned virtual hard disks by exporting and importing the virtual computer. 2. Mount the newly cloned virtual hard disks by doing one of the following. Double-click them in File Explorer. Use diskpart.exe with the assign command at an elevated command prompt. Use the Mount Disk Image Windows PowerShell command. 3. Use the offline and path parameters with the new-add-clone-config-file command. Change EAST to the drive letter that you used when mounting the .vhdx file in the previous step, as shown in the following command. New-add-clone-config-file, clone computer name, LON, DC3, offline, path, e/windows/ntds. 4. Unmount the virtual hard disk files by using diskpart.exe or the dismount disk image Windows PowerShell command. Using dynamically assigned computer names. If you do not configure DCCloneConfig.xml with a static computer name, for example, to create multiple clones without individual configurations, the computer name of the new clone is automatically generated based on the following algorithm. The prefix consists of the first 8 characters of the computer name of the source domain controller. For example, the source computer name source computer is abbreviated into the prefix sourceco. A unique naming suffix of the format, CLNNN, is appended to the prefix, where NNN is the next available value from 0001 through 9999 that the PDC emulator determines is not currently in use. Creating the virtual domain controller clones. To create the virtual domain controller clones, follow these steps. 1. Ensure that the domain controller, which holds the PDC emulator FSMO role, runs on Windows Server 2012 or later. 2. Ensure that the PDC emulator and a domain controller hosting the global catalog are online. 3. By using the exported files from the preparation steps, use the import function to create as many clones as needed. When using Hyper-V, select Copy the virtual machines, create a new unique ID, to allow you to import multiple individual instances of the same exported computer. 4. Individually configure clones as required by following the previously outlined steps. 5. Start the clones. Finalizing the domain controller cloning. When a new domain controller clone starts, the following steps take place automatically. 1. The clone checks whether a virtual machine generation identifier exists. This is required, and if a virtual machine generation identifier does not exist, the computer either starts normally when no DCCloneConfig.xml exists or renames DCCloneConfig.xml and restarts in DSRM. Starting in DSRM is a safeguard, and a domain administrator needs to pay close attention and fix the issue to make the domain controller work as intended. 2. The clone checks whether the virtual machine generation identifier changed and takes one of the following actions accordingly. If it did not change, it is the original source domain controller. If DCCloneConfig.xml exists, it is renamed. In both cases, a normal startup occurs, and the domain controller is functional again. If it did change, the virtualization safeguards trigger, and the process continues. 3. The clone checks whether DCCloneConfig.xml exists. If not, a check for a duplicate IP address determines whether the computer starts normally or in DSRM. If the DCCloneConfig.xml file exists, the computer gets the new computer name and IP address settings from the file. The ADDS database is modified, and the initialization steps continue, thereby creating a new domain controller.